Algebra 2. This is Unit 8, Lesson 1, and today we're going to talk about square root functions. Alright, so square roots are the natural inverses of squaring. In other words, to find the square root of an input, we must find a number that when squared gives that input. Alright, so this is used a lot in higher level math courses. It's important to understand their graphs, their domains, their ranges, so we're going to go through all of that here. So consider the two functions. First one is f of x equals square root of x, and the second one is g of x equals the square root of x plus 3 minus 2. So let's graph y equals f of x without using our calculator. So I'm going to plug in 0. The square root of 0 is just 0. Plug in 1. The square root of 1 is 1. Plug in 4. The square root of 4 is 2. Plug in 9. The square root of 9 is 3. Notice I'm just picking perfect squares here. Square root of 16 is 4, and square root of 25 is 5. All right, so now I'm going to graph that. So I got 0, 0, 1, 1, 4, 2, 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And that's about as far as I can go on this. And my graph would look like this. Okay, grab a different color. Now, using your calculator, let's generate a table of values for y equals g of x on the same grid and label its equation. So I did these already. We're going to start your table at x equals negative 10. All right, so if you plug this into your calculator, so in your y1, you're going to plug in the square root of x plus 3. Then make sure you come out of the square root, so hit the arrow to the right, and then you're going to do minus 2. If I plug in negative 10, or when x is negative 10, this is all going to say error. Okay, we cannot have the square root of a negative number. So these are all error until I get to negative 3. So negative 3 plus 3 is 0, and the square root of 0 is 0, so this gives me negative 2. So that's the first number that works. Plug in negative 2 plus 3 is 1, square root of 1 is 1, 1 minus 2 is negative 1. 0 gives me a decimal. I plug in 1, 1 plus 3 is 4, the square root of 4 is 2, and 2 minus 2 is 0. I just want to show you that some of these you can do in your head as well. Like if I plug in 6, 6 plus 3 is 9, square root of 9 is 3, 3 minus 2 is 1, and I'll just copy the rest of these. All right, so my first point is negative 3, negative 2, which is here. My second point is negative 2, negative, oops, I went too far on that one, sorry. Let me erase that. So 1, 2, 3, negative 2, negative 2, negative 1. 0 is sort of in between. So 0 is negative 0.08. 1 is 0. 6 is 1. 1, 2, 3, 4, 5, 6 is 1. So it sort of goes like this. Now, if you think of what we learned about transformations, this makes perfect sense. I took that parent function, which is y equals the square root of x that I'm highlighting right now, and you can see I shifted it over to the left 3 and down 2. So this 3 moved it to the left. Okay, so this went to the left 3, and the negative 2 went down 2. All right, let's state the domain and the range. So this should say y equals absolute value of x. So the domain is going to be 0 to infinity. So I'm looking at the red graph. Let me write this in red, actually, so it matches. So the red graph, that parent function, I start at the domain of my x's, 0, infinity. All right, and my range... for some reason I didn't, I guess we don't have to do the range. I have range on my paper, but I guess I took it off. And then for this one, I have the square root of x plus 3 minus 2. You can see my domain shifted, so my domain is going to be from negative 3 to infinity. All right. So thinking of my transformations, let's do exercise 2 right here. My normal parent function graph, right, looks like this. And then, so this was y equals square root of x. But you can see this one is upside down. Plus, it's also been shifted 1, 2, 3, 4 to the, shift 4 to the left. Plus, it has been reflected. So looking at our multiple choice, remember when I do a reflection, that puts a negative in front of it. Okay, so here's negative, so it could be either of those. But I reflected it and I shifted it 4 to the left, and a shift of 4 to the left means that you're actually adding 4. All right, so let's talk a little bit about these domains that are going on. So we did this back in the beginning of the year. So just remember our domain, when I have a fraction, the denominator cannot equal 0. So in order to find my domain, I'm going to take my denominator, set it equal to 0, and solve. Okay, so I cannot have it equal 3. It can be any other thing, but it cannot be 3. So it's all real numbers, except it cannot be equal to 3. Now remember when we did logs, it can't be equal to 0, or it can't be negative. So in that case, I'm going to take that x minus 3 and set it equal to greater than 0. You can't do the log of 0. You can't do the log of a negative number. So that's going to be x greater than 3, right? And when I have a square root, it can't be negative. 0 is okay, but it can't be negative. So I'm going to take the 4x plus 20 and set it equal to greater than or equal to 0. So 4x is greater than or equal to negative 20. X is greater than or equal to negative 5. So those are my domain restrictions. All right, which of the following values of x does not lie in the domain of the function? So basically you just take, when I have a square root, it can't be negative, so I'm going to take what's under the square root and set it equal to greater than or equal to 0. So basically any value as long as it's greater than or equal to 5 is okay. I'm looking for something that does not work. All right, so 6 is greater than or equal to 5, 5 is greater than or equal to, and 7 is. So here's my answer. You can also just test out your answer choices by plugging in 2. Like if I was to try and do the square root of 2 minus 5, I'm plugging in 2 for x. I can't do the square root of negative 3. Okay, you're going to get an error. It's not a real number. We are going to talk about this in the next unit, but for now, it is not a real number. All right, let's determine the domain for each of these following square root functions, since we're talking about square roots in this unit. Show an inequality that justifies your work. So the only thing to remember is you can't take the square root of a negative number. So all you do is you take each of these expressions underneath the square root and you set it equal to greater than or equal to 0 and then solve. All right, so basically negative 2 is okay, and anything greater than negative 2 is okay. Take 3x minus 2 greater than or equal to 0, 3x greater than or equal to 2, x is greater than or equal to 2/3. So again, 2/3 is okay, and anything bigger than 2/3 is okay. And the last one, we've got to be a little careful with our signs here. So 8 minus 2x is greater than or equal to 0. I bring that 8 over to the other side. Now remember, when you're dividing by a negative number, that I have to flip that inequality. All right, so x must be less than or equal to 4. So 4 is okay, and anything less than or equal to 4 is okay. All right, so we got to switch the inequality on this one. All right. And number 5 is going to be a little tricky. I have the function the square root of x squared plus 4x minus 12. So you want to use your calculator to sketch the function. So if I go to my calculator and I go to y1 and I plug this in, all right, I'm just going to copy down some of the values that I have that are integers. Oops, I have, do that wrong, negative 7,3 is 1 point, negative 6,0 is another point, 2,0 is a point, and 3,3 is a point. All right, so I got negative 7,3, 1, 2, 3, 4, 5, 6, 7. Negative 7,3 is about here. We got negative 6,0 is about there. I got 2,0, and I have 3,3. All right. Well, let's see what this actually looks like. I can hit the graph button, but I also know a little bit about quadratic inequalities already. Remember, when it is greater than, okay, the solutions are outside. when it's less than, the solutions are between. So if I was to take x squared plus 4x minus 12 and factor it, I got x plus 6, x minus 2. So x equals negative 6, x equals 2. And then you can just test out choices just to see which one works. But basically, it's x is less than or equal to negative 6 because it's going this way. All right. It's a little messy, sorry. And also, or x is greater than or equal to 2, and it's going this way. So that's what my graph would look like. All right, so that's a square root of a quadratic. All right, we're going to practice all that tomorrow with that domain and range and our square roots.